Hello everyone and welcome to this tutorial. In this tutorial, we'll be spinning up infrastructure on GCP Google Cloud Platform using Terraform. We'll be doing a lot of infrastructure as code, and the intention, the drive that we will keep during these recordings is to use as much as of code. So a lot of CLI, a lot of scripting, a lot of infrastructure as code with Terraform as well. Um, I'll just give a brief about how my system is set up as of this moment. I am using Windows 10, and on top of that, I am utilizing Windows Subsystem Linux with Ubuntu 18.04 image uh, installed on it. And if I can share with you, let's hop on to the root directory, or let's hop on to home. Just cd pwd home, or mramsrup is my user. And basically, if you hop back, what Windows Subsystem Linux does, the image creates a mount, and in the path, it creates a space in your system, a memory that will be dedicated to the Windows Subsystem Linux. It's the image that I've used is 18.04, Ubuntu 18.04, and that we can verify that by getting out .hcos. Sorry, that's supposed to be OS release, and there we have all the details of the image that we'll be using during these recordings. I also have Google SDK installed on my system on this Windows Subsystem Linux on this Ubuntu image, and I pretty much installed it. The installation is pretty much easy if you go and navigate to the Google Cloud Platform documentations for Google to install and download Google Cloud SDK. I have not yet set up my Google Auth and other things in account, so we'll go ahead and set up that as well in a bit. The other thing that I wanted to show you is now the Google Cloud version. So if I gcloud version, I have currently installed the Google Cloud SDK with version 2.8.4, along with the components of the SDK, Alpha, Beta, BigQuery, Core, GSUtil, and kubectl. We can check the current list of components using gcloud components list. So it gives you a list of available components, installed components, and not installed components. And as we saw earlier, these are few of the installed components that were installed while the gcloud SDK was initiated and installed. The other thing that I would like to show you first is gcloud config, because I was playing, I had set this up earlier, so we might be having a default configuration list. That is because, yes, so for this first recording, I'll just use a pre-existing project that I've already made, and I've configured my Google Auth with these details. But moving on in future recordings, I'll exhibit how we can make use of gcloud CLI to create a project from our with the help of code, and then moving on to deploying resources using Terraform inside that project. Because if we understand correctly, within Google Cloud Platform, all your resources are contained inside a project. So project layer contains all your resources, and project is the basic, if I may say, resource that you will require to spin up your and provision your resources using anything. If it may be Terraform or deployment manager, but that's the way. That's the basic entity or resource that you would like to spin up. For this demo, I've already spun up a resource. I'll just give you a preview of what's there. If we move on to home, yes, that's my project ID, which coincides and is exactly to the one I've configured. Now the way, okay, we can do one more thing. I'll be recording these sessions live, so I will be coming across a lot of errors and blockers, but my intention here is to include them as well as to see how we can also troubleshoot them going forward. So the first thing that I would recommend is that to download Terraform on your machine. I have it's also a very easy process to do. What I've done, what I did was I navigated to terraform.io URL, which is the uh, uh, official web uh, web URL where you can get all the documentation and everything you want to know about Terraform. Moving on from there, if you go into the download section, you'll find this page where you can choose the operating system that you want to work with, and it should download the appropriate package for that particular operating system, of the architecture that you of your choice. And once it's installed, I went ahead. Let me just check if I've installed it. Usually I go ahead and install it in my OPT directory, but we'll check. I think I had deleted it, so we'll go ahead and check what's in our OPT. It's there. Let me just check if it's installed. -v. It's installed, but I know what's. I have not exported the path yet, so I'll do that right now. Export path. I'll export it to the location where it can find the Terraform script to activate Terraform. Let's try Terraform again. And yes, I downloaded version 12 because I want to work with the latest version. I think the current version, as it says, is 24, but I'll keep it to 12 for this demo. So we have authenticated G-Cloud as well. I'll just try to check the configurations list one more again. There'll be a lot of commands that we will keep repeating, and it's just the fact that gives I don't I also wanted to share that I don't come from a development background. So over the years, for last 3 years, I personally have gone from having absolutely no clue about developing, and today I feel a little more comfortable with while writing the code. Uh, so some of the commands, or some of the approaches, or some of the uh, uh, things, or things that you would find here would be repetitive, but that would I would try as much as possible to share uh, what's the intention that we are trying to do here. Okay, so config, let me just check the current config list, which is active and default. Let's start with I just wanted to show how you should always start while for authenticating with your Google Cloud SDK. We start with gcloud init. It will give us the option to reinitialize the configuration, default to new settings, or create a new configuration. We'll just reinitialize the first one. It'll do some network connection diagnostics, and these are the previously available, because I was working with these accounts. that the network identified on this system. So I'll be working with the first one here. It's already detected the account, and now it's showing me the list of projects available in the account, and I need to hit the number that I want to work with. Our project was 9, so I'll go ahead with 9. Do you want to configure default compute region and zone as of this moment? Not really. We'll do it later. And seems like we are good to go and all set up. So gcloud init was one command. Another way to log in and authenticate with your SDK with Google Cloud Platform is Google Auth login. I'll not do that as of now, but we'll first go ahead and check the auth list that is available to us. And as we saw in the options that were given to us while we were trying to authenticate the account, there are 2 accounts as of now that are credentialized account and are available to us in our configuration when we list out the auth. And if you have multiple accounts, the way to log in into account is I'll not create, but I'll just try to log in my another account just to exhibit this process. It should generate a web URL link. I won't be able to copy. I'll just click it this way. It'll ask me the sign-in details. Yes, this was the username that I requested to sign in. Oops, no, that's not good. This will ask and prompt us to allow the account to make authentication with the Google Cloud Platform and generate a hash value, which we'll have to copy, go back into our terminal and enter here. Looks good. And if we go again and check the auth list, there's the new Google account that we verified with, and it got activated as well. So just to be careful, again, I'll just check my configurations list if there was any default. Yes, the account changed, so I'll have to make sure. I can work with this account as well, but I'll just have to make sure that this user has all the IAM permissions that I might require. We'll just double check. But anyways, this was just to exhibit that the way to authenticate using CLI and not working with the interface to communicate with Google Cloud Platform in a controlled and with the identity. Check security center admin. I won't be able to. We'll just switch back to admin because I know admin has all the owner permission. Oh, sorry, the owner role attached to it, so that wouldn't be a problem. While working with Terraform, we'll have to create a service account, and now I'll take the opportunity to exhibit that as well. So it's a good practice that to work with Terraform, which will be a sort of automation of spinning up your infrastructure and provisioning your infrastructure. You would certainly resort and would like to create and do it through a service account to not involve any manual intervention while Terraform is performing and spinning up your infrastructure and provisioning your infrastructure in your environment under your project. So we'll go ahead and name the service account as Terraform SA 126. No, we'll just 001. We'll just mimic the project ID numbers. Description: Terraform service account for project / Terraform nation 001. So that brings a little specificity when we create this service account. Actually, we only require a key service, key identity, a key that will create in the end. But to authenticate Terraform with it, with our provider, Google provider. But it's a little more secure that we do it using a service account, and a service account identity is attached to that key. It's more secure. One big reason. We'll give our service account the role of an project editor, so that it can have access to all the resources. For a project editor, I don't think they have access to the IAM, that they can give access to other IAM users and identities, but everything else comes under the scope of this role, pretty much. So we'll go ahead and continue. We do not want it to be controlled and doing anything. I'll just go ahead and create the key. It should be of JSON type. That's something to understand. And what I'll do is I'll go into my folder. This is the latest one, and I'll just rename it information 1. Just to be specific, because I don't want to end up using another project's key or another service accounts key. We have this here. We'll currently let it be in the downloads folder. Close this. The key has generated a hash value, and the key ID, which is 6761. We'll be using this key very often now. I'll go back to the home screen of my project. As of now, no resources. All right. Now that we have Terraform installed and G-Cloud authenticated, all right, we'll hop on to using VSCode. I'll be using VSCode during these recordings, throughout the recordings, to code my infrastructure, and also to utilize the terminal, integrated terminals. It's really a wonderful IDE from Microsoft. So what I've done is cd workdir cd olive tech cd. So I've created a directory called Terraform, and inside Terraform I was goofing around with Terraform a few times ago, so that's why I started with a getting started directory. Let's dive into the getting started directory and see what's in there. This is really painful, I guess, but I have some sort of organization, so that's why. Yeah, so we have all our files here, but what we'll do is instead getting started, mkdir demo 101. Yeah, cd demo 101 ls, and we have an absolute empty directory where we'll start coding using our Visual Code Editor. I'll have to reopen it. Oh, that was in VSCode. Sorry, sometimes you might find me losing track of my chain of thought. It's very typical, so that's fine. Yeah, demo 101. There it is. Worked cd olive tech Terraform, getting started, and demo. We are here. We have nothing as of this moment. So the first thing that I'll do is I'll create a file which will name is main.tf. ls main.tf. Sorry, we can see that here. Let's go and hop onto this file. We'll check the. It's always with grinding for 3 years, I've understood with time that documentations are the best place to start getting your hands dirty, and I would appreciate Terraform to have a very robust documentation and library to get information with them. So the first there are certain there's a certain architecture that Terraform works with, is like it's like a client server. I understood it as a client server. So the server will hold your current state of configuration that you will be planning and deploying using your Terraform application or from your authenticated machine. The first thing that stands out with Terraform, it's cloud agnostic. It's not tied up or locked down to a particular cloud. You can spin up resources on all the providers which are available with Terraform, and the provider list uh, is actually long. This is the Google one. We'll go back. So this is the provider. They have providers for major cloud infrastructure, software, network, version control system, databases, community, and all those clouds. So, but we for this demo are interested in Google Cloud Platform. So, the way to authenticate is with Terraform with your account and your choice of your cloud platform is by providing a provider's block in your code. What provider block does is it is used to configure your Google Cloud Platform infrastructure. Um, Pretty much basic. Does initiates and authenticates the session between your Google Cloud Platform account and your machine that will be used for deploying the infrastructure and provisioning the infrastructure. It basically the required keys in provider block to activate is credentials, projects, and regions. Now, what credentials is equal to the value of a file, the JSON file, the JSON key that was created for our in our case, the identity that we'll be using to deploy the infrastructure is the service account, which we named Terraform SA. So it will be pointing to this file. uh, this provider block will help, this file will help the provider block to authenticate Terraform so that it can establish a sort of a TCP connection where it has the definitive information about the client, and it will be getting the instructions from. For this purpose, as I mentioned, I have already created a project. So the value would here would be Terraformation 001. The region will choose Asia, South Asia one, because that's the closest data center for me, as I am recording these sessions live from Mysuru. Moving on, so we'll just start coding. I'll just pick up this resource block from here, from the documentation, paste them in my main.tf file. Hang on, and where should ls hang on, ls, the downloads file, sorry, the downloads directory, let me just check, yeah, and the name of our file was, we'll copy this, go back there. So just oversimplified. I know it's a very long recording, but I'm trying to simplify and give as much as information as I can about this first deployment, because it's a very necessary, and we'll start. My intention is that we go step by step. Anyways, if you're watching this, you're working from home, so you have ample time. Thank you. Terraform, it's there. So what we'll do is we'll copy this from this location to our current directory, current present working directory. No such file or directory. I know, because I left out the JSON. Okay, ls, yeah, it's there. This is not a good practice, I should mention, but moving on, in future recordings we'll be looking how we can more and more introduce automation and also security in order to spin up our provision our infrastructure in a more robust and secure way. But this is an oversimplified introduction to Terraform on Google Cloud Platform. So so the file that I can pass now in the credential block I'll try to is the file name that I've got here. Actually, I'll pass the whole path. Let's try the path first so that we have an understanding of what we are doing. I'll have to pass this as a string, demo 101, and the file name would be let's try to authenticate with this first. So as of now, nothing yet. We have just created our let's do the region. Let's just use another region. South 1. Save this file. Project ID also need to be changed. Terraformation 001 again. Now we are all set. So there are a few commands that I like to we are all set to introduce to be introduced to some Terraform commands. As of this moment, if you want to establish an analogy, we are at we are at the gates of Google Cloud Platform data center, and you can imagine us as uh, wearing a uniform, which is, say, Terraform's color is blue. Actually, I'm colorblind, so I wouldn't recognize if that's incorrect. Please spare me. But we are wearing a uniform that Google Cloud Platform employees identifies as Terraform. We have not yet. We do have that uniform in our bag, and will be using the command Terraform initialize to wear that uniform, so that the Google Cloud Platform can go ahead and they can realize, oh yeah, there's a guy that I have from Terraform, and he'll be doing stuff in my in my environment in this particular account. He'll be spinning up some infrastructure just like Lego and building up infrastructure like that. um, and also what I need from him is, while I do all that stuff, is to authenticate himself with the particular set of um, credentials that I ask this Terraform guy for this account. That should be relative to the account, and that's why we did the whole process of generating a service account with the key, uh, all very oversimplified at the moment. So the first command that we got introduced in is Terraform init, because we'll have to initialize this current working directory for Terraform. The command not found, and that is because I'll have to export my path again. Path, it resides in my opt/opt directory, and Terraform. Another command, I'll take this opportunity, is Terraform show. So as of now, because we have not even initiated, this should return back an error, but I'll show you why it is one of the uh, uh, key commands that I use as often as ls. Terraform init is the one that we are looking forward to. It started initializing the backend, and it is I don't remember giving this instruction to our file about plugins. We'll deep dive in what it means by plugins, but it has actually gone ahead and successfully initialized. The version is 3.13. It took the latest version. All right, so just to verify, we'll just check what got created in our directory. Nothing. Let's just check the hidden directory. Oh yes, there we have a hidden directory called .terraform. We'll just ls into .terraform and check what sits in there. Plugins. So the mystery that was around provider plugins is that when you initialize a Terraform directory, it will go ahead and automatically create the hidden directory. Within it, it will create the plugins. Let's now we have the because we have to keep a curious mind. We should go and look into what's in a plugin. So ls Terraform plugin Linux, and that is because when we initialized the Terraform directory, the operating system that it identified on Windows subsystem Linux was Linux, and that's why it created a name directory with Linux. Had we been doing this on using Windows operating system, then I'm pretty sure this would have been something with other name, like default name that Windows gives. All right, but it opens again path for us, and let's go and check what's in this directory. There are two files. It gives me an input output error because I believe this is a binary file that with the name Terraform. We'll just check by catting it out. Cat Terraform. Oops, that's not good. That was my key. I'll have to edit that. It should give me an input output error. That's what I've always got with this. Oh, that was ls, that was not cat. I'm so sorry. Input output error. Then we'll investigate the other file. The log.json. Now we'll have to understand. You'll understand after having a look at it, and this will be surely will be gone once I end this demo, because I'll take away all the credentials and all the files, and I'll have to do a cleanup for everything that I'll be using in this demo. So the log.json creates a hash value, I believe. I'm not sure about it. I've not read it, but this is what it sees. It creates a hash value for the provider particular to our account for this machine that will also be treated as um, the local state of our configuration. Remote state being the one uh, that will be tracked by Terraform application, which is Terraform state file, TF state file. So the client server architecture in such a way, the server being always being the TF state configuration file, and the one we have in our local state being the local state file. The approaches that we usually take with Terraform, moving and planning our architecture on a particular cloud, is to create a state file and then keep incrementing, keep adding resources to your current state of your configuration, and that helps, and it becomes effective because of the characteristic of Terraform being idempotent. Being idempotent could be easily reflected with the example that if I create a storage bucket and I forgot to put certain labels on the storage bucket that I wanted to, and my manager had asked me to, um, I can go ahead and delete and recreate it, but recreate the bucket again. But what with Terraform being idempotent in nature, what it'll do is it'll not recreate the resource until and unless we don't instruct Terraform to. It'll just go ahead and add the tags on the existing resource, because it will have the information of the existing resource with the help of certain IDs and hash values that are present as of that moment in the state file. So if your state file holds the information of your storage bucket as of at that point of time, and you would like to update labels on that particular resource, which is also identified, which was earlier identified by Terraform, it will only add those labels to the resource unless and until instructed to forcefully recreate the whole resource. So that is one big important thing that I found useful with Terraform. Sorry, as of now we have Terraform, but we have not. So let's go ahead and do a Terraform show. No state, because we do not have the TF state file for now. Terraform plan, Terraform show, and Terraform validate. The another command that I would like to introduce in this uh, recording is Terraform validate. What it does is it validates the current set of my configuration, which is success, because I'm just for now we are just authenticating. We have just authenticated, and that looks fine. There's a reason that I'm delaying the Terraform apply, because I want to apply my storage account as my first deployment. That's why I'm not yet moving on to Terraform apply. And there's one more command that I would like to introduce before I move on to Terraform apply, is Terraform plan. Terraform plan is a great feature that I find with Terraform, because it gives you the exact resources and the provisioning details that will be done depending upon the current state of depending upon your TF file, the main.tf file. It identifies the extension .tf and then reads the code inside the TF file and spins up infrastructure according to the codes, which makes it infrastructure as code completely. So we'll just hit Terraform plan, and I think it would not show any resources because it's just a authentic provider block. Yeah, as said, it will not show, and I wanted to exhibit that how we can how great this plan feature is, and that's the reason I would like to add the most simplest of resources, which is a storage bucket. And how do you look for documentation, for resources and documentation? What I do is I do Control F, I do Google storage resources, yeah, storage bucket. We'll just spin up a bucket. Now the way Terraform, now this is HashiCorp configuration language. It's specific to Terraform, it's specific to HashiCorp, which are the parent company of Terraform as a product. And the way this language works is you'll have to define a resource to provision a resource. In Google, you'll have to define its resource type. First of all, the first block would be the after resource will be resource type, and then the resource name. And I got confused in the beginning that this resource name is something that we would see on the console on GCP platform, but it is the resource name that will be identified by Terraform. So Terraform state, Terraform as a service, Terraform as a server, or whatever you want to call it, or Terraform as an application will identify your resource of type storage bucket as the name that you provide here in the resource name section. This block will contains key values of different properties that we want to go ahead with. Few of them key values are required. So if you don't provide those values, this they'll never validate and they'll fail. You can scroll down and look at them. I find on the name being the only required minimum required section for my storage account, storage bucket resource block. Also the location, because we'll have to when we create a storage bucket inside and through using console, we do need to specify where our storage account resides, because that's how that's where our data will reside moving on. So I guess this also becomes required block. But what we'll do is because we are just planning, and that's where the fun begins. We are just planning. What we'll do is we'll just first plan with this without the location block, and name Google Cloud Storage static site demo bucket name Terraformation bucket, and we need to end our braces. That looks nice. I'll save it. Terraform show. Oh, if I could write it, no state. Terraform validate Terraform plan, and the flag that we'll be using is out, and what it does is it will text out, it will print out the plan, the current plan that I have, including the resource of bucket into a text file, into a binary file, which we can name it as we want. So I'll be deploying storage bucket, and we are keeping location default. So I'll just say default. We are expecting it to take default. Let's see what it plans for us. Looks like that we have now a resource block. It can show that what we are planning to do. It has taken the demo bucket. The resource will be identified in Terraform as demo bucket. And wonderfully, the location that it took by default is US. So this exhibits how important plan can be. We don't want to run in US, but we still have a plan file which we can always use for a deployment in US by tweaking a few things. It's actually a binary file, so I'm not sure if we can tweak things, but we can do stuff with this file. Moving on, so I don't want to deploy in US, so what I can do is I can go and add default Asia, and in my code I can choose the location as, I'll add the location as Asia South 1 location. Location is not in this format, so I'll just change it to say Europe. Yeah, now that's the correct format, and over here we'll change it to Euro. Okay, so our plan is ready. We shall be good. Perfect. This looks nice. So we'll do is Terraform apply. What we can do is we can do Terraform apply as well, to apply the current state of our configuration. But what Terraform apply, okay, I'll show what Terraform apply does. It'll plan and it'll prompt me for a value to enter. So you'll have to do it again and again if you're just using Terraform apply. For now I'll do it no, because I wanted to show you, if you want your plan to be applied straight away, you can go ahead and apply your plan file, and it will not prompt you for a yes, and just directly go ahead and in creating your resources that you've asked it to create. First, it suggests us to do a Terraform show, so we'll just do a Terraform show. Looks good. It's got all the details of the resource that has been created, any changes in a directory, and there is our tf state file. Those are the two plan files that we created. We would keep a track of them if required, and just cat out the Terraform state file. Yeah. Now this contains a lot of hash values and MD5 authentication values, like some primary data as well, which will be gone, because once we are done with this demo, I'll go ahead and destroy everything. But it shows that the automation that works behind using Terraform is actually very robust and fantastic. Creates an object for each and everything that gets created while creating resources on a particular cloud platform. ls minus al. The last bit that I wanted to show you now is that I want to get rid. Oh, look, let's just check if our resource got created or not. And if you realize, our resource that got created was pretty quick, which was like 2-3 seconds. So that shows why it's such a popular tool across all cloud platforms. Terraform. We'll go into the storage section. There is our bucket, Terraformation bucket. Terraformation bucket. And we'll just go ahead and check some details. The location. Won't be able to check from here, I guess. location EU. All right, so this was a successful deployment, our first deployment with the resource. Now, just to be sure, I can go ahead and add a label. Labels are added as, hang on, let me just check the documentation. Just want to verify how labels are provided. Yeah, comes under the after. Okay, labels. Labels, I'll say environment demo. That works. Let's check. Nope, that doesn't work. We'll add okay. By adding labels, I just wanted to show the idempotent nature of Terraform in this one long video as introduction. Let me just Google through it. As a list, we'll have to pass labels. I just want to be sure how we pass the label key value pairs, and for that I'm trying to find the compute engine resource because I can get some idea about labels, how labels are passed in there. Yes, so that's the label block. I'll just copy it from here for the sake of this demo. I'll properly put the indentation. I have no clue what I'm speaking. Should really not be bothered about the accent. Anyways, here we have, what I'll do is D DevOps. Looks good. We'll try to validate. And yeah, Terraform plan. We'll plan it out as deploy tags storage bucket dot dfm. And even in the plan, it will show that it'll just add 0 and only change one thing. So that is what idempotent means, that it will not recreate or touch the existing resource, but it will just change what you have added into the resource. We'll just go ahead and now apply this plan and see how it changes our infrastructure. Earlier we saw that it was creating the infrastructure, but now it read in the Terraform state file that the infrastructure is just being modified, it's not being recreated. So that is what the power of Terraform and what it means by idempotency. It means Terraform show again. Looks neat. And there's our label. We can confirm that while navigating to our storage account. give it a refresh again. I'm not sure. Yeah, there it is. Team DevOps, the labels. That looks neat. Last bit, the last command that we need to introduce ourselves to for with Terraform is Terraform destroy. And what this will do is it'll destroy the current state of my configuration and delete everything. So we'll just go ahead. We don't need to plan this, and this first demo, it's already too long. I guess I'll just enter yes. And if you check now that you have state file, if you cat it out from df state, it's gone back. There were resources that we saw before. The lineage didn't change though, so that is where this is the hash value that was identified and given and provided to us to our connection with Terraform and the configuration and with respect to the Google account and the resources that we were provisioning. ls, we have our plan files as well, and if you try to again apply one of the plan files, I guess it won't work, which we can try. Terraform apply deploy default. Let's start with default. Yes, so it works because actually there wouldn't be, oh yeah, we can actually check whether, because this time it will be in Singapore location, oh sorry, in US location. It got recreated, I'm pretty sure, and location changes to US because this was the plan that we made with the default. Terraform destroy. Yes. And if you refresh, it's gone. So cf ls, we've got everything perfectly aligned for our next recording, where we'll start getting into automation and start using best practices. In this particular video, it was just a simple 101 oversimplified introduction for for Terraform and how we can use it to the commands that we can use it to provision infrastructure in Google Cloud Platform. From the next recording, we'll start looking into how to be more. We'll start looking at the automation part of Terraform and how um, we can implement DevOps practices. Also, I would like to touch upon how we can incrementally deploy infrastructure inside our Google Cloud Platform using Terraform. I know this session got extended a little bit long, but I wanted to touch not each and every aspect, but all the important commands of Terraform, and wanted to exhibit uh, their usage. Hopefully, that was all informative and uh, was something of benefit for all of us. If you have any recommendations, suggestions, and comments, please comment them in the comment section, and we'll be more than happy. I'll be more than happy to introduce those changes and suggestions included in our future recordings.